Alright, this video is on electron configurations for D-block elements. So we are focusing on these guys right here. And we're not going to focus so much on the F block. Even though the same rules would necessarily apply, we're not really going to deal with too much F block stuff. It's going to be mainly D-block. Alright? So, let's go ahead and do a normal electron configuration for, say, something like, just a refresher, phosphorus. Alright? So here's phosphorus. When I look at phosphorus, I see it has 15 electrons, right? So it's somewhere in here, right there somewhere. So I know it's in this 3p orbital, so I'm going to do my orbital diagram, right? So I know I want 1s, I know I need 2s, I know I'm going to do a 2p, I know I'm going to need a 3s, because I have to get to 3s, and then I have a 3p orbital here. It is 15 electrons, so I'm just going to fill in my electrons as I go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so there's my 15 electrons. Alright, so looking here, I have 3p and then 3 electrons here. I have 3s, there's 2 electrons, 2p, there's 6 electrons, 2s, there's 2, and 1s, there's 2. So my electron configuration is 1s2, 2s2, 2p6, 3s2, 3p3. Okay, so hopefully you got that as an ease. That should be reviewed. Now we're going to redo the same thing, or use the same concept, but we're going to do a D-block element. Okay, so the D-block element I'm going to choose is vanadium. Let's choose vanadium. Vanadium has 23 electrons. Okay, and like I said, I know there's 23 electrons because there's 23 protons. I'm assuming that the atom is neutral. Vanadium is right about here on the periodic table. So if you look at the diagram that I have right here, you notice 4s in the fourth potential, the fourth energy level, the fourth principal energy level, is in the fourth row, but the 3d is also in the fourth row. Okay? The reason why this is because before the 3d orbital fills, the S4, the 4s orbital is going to fill up first. Okay? So this is just a kind of a little exception to our rule of looking at period will give us the principal energy level. Okay? It's one we're going to have to remember. Right? So our 3d is actually in the fourth row, our 4d is actually in the fifth row, our 5d is actually in the sixth row, even though I'm not going to give you anything probably past the third row. Okay? Just because I want you to be able to do it, I'm not going to spend a lot of time testing you on if you can do a D-block, but I do want you to know how to do one, because you will be doing at least one. Okay? So, looking at vanadium, I know that my my 3D is my 3D block. Okay? So, I'm going to start off with my 1s, right? And then my 2s, and then my 2p, right? Then I'm going to go 3s. Now, here we go. We go 3p, right? Now, you think, oh, I'm in the third energy level, right? So I would go 3d next. But if you follow the order of the periodic table, 4s will actually come before 3d. So I'm going to go 4s, and then I'm going to go 3d. Now remember, D-block can hold up to 5. Right? I'm not going to fill those last ones up. Okay? Orbital blocks are here. Right? One, two, three, four. Okay? And that's our 3D. So I'm going to fill in my electrons right here. Good, right? Should look all the same. Okay? Proper way to do the p orbital. Here's my 4s, and then I have 3d. So let's count my electrons had 1, 2, 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I need 3 more. 1, 2, 3. Okay? So my electron configuration in this case is going to be 1s1. Oh, sorry, 1s2. 2s2. 2p6. 3s2. 3p6. 4s2. And 3d3. Okay? So that would be vanadium. Alright, so your 4s is filled before your 3d. Alright? Now, that's if we're going in the middle of the D block. What if we actually go all the way through the D block? Let's say I wanted you to do electron configuration for selenium. Okay? Selenium is located in the 4p orbital. Okay? It's right about here. Oops, I'm off a little bit. Let me fix that. Alright, so 4p right about there. Okay, so that's where selenium is. Selenium is number 34. Selenium is number 34, so we can assume that it has 34 electrons. Alright? Now, when I go through there, and I'm getting all the way to 4p, remember, when I'm passing through the 4th energy level, I have to pass through the D block, 3rd D block, or 3D orbital. So, let's do my orbital diagram. There's my 1s, there's my 2s, there's my 2p, 3s, 3p, 4s, 3d, and then I have the 4p orbital. Okay? So let's fill out our electrons. Right? I'll go ahead and pause the video so you can get caught up. Right, go ahead and fill them in, and I'll fill them in too. Okay, I went all the way to fill the 3p, and then I'm going to do my 4th energy level here. So there's my 4s, and then fill in all of the 3ds halfway through, and then fill in the rest of them. Right, so there's my 10. And then how many do I go into my 4p? Well, I need 34 right here. By the time I get to the end of 3d, right, by the time I get to the end of 3d, I will add 30 electrons, so I need 4 more. Right? I know it's 30 electrons because if I counted all the way up to this point right here, I'd have 30. And now I need to do this little section left over, and there should be 1, 2, 3, 4, 1, 2, 3, 4 to get to selenium. So 1, 2, 3, 4. Okay? So there's my orbital diagram. So let's go ahead and do the electron configuration. Actually, we'll go ahead and do the abbreviated one, since we know how to do that now. I looked at the most previous noble gas to pass, and that should be right there in argon. Okay? So argon is the end of the 3rd energy level. So here's my 1st, 2nd, 2nd, 3rd, 3rd. So right about here is where argon is found. Okay? So now I'm left with 2 here, 10 here, and 4 there. So that would be 4s2, 3d10, and then 4p4. Okay? So that would be the abbreviated. Obviously, if I did want to do the long one, it would be, I'm not going to write it out, but 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p4. Okay? If you guys have any questions, allow me to ask. I do have one for you to nibble on, or actually a couple. Okay? I would like you to give me the electron configurations for, let's go with iron, bromine, and strontium. give those a shot, and then you guys have any questions, ask me in class, and that's about it.